Okay, the first thing on my agenda is to make sure that everyone is on the same page regarding to the special trig limits. So I hope this is not stranger to you all. What does that equal to? Yes. And then the other one, it's limit as x approaches to 0 for 1 minus cosine of x over x. It's equal to, that would be 0. Okay. Now, in terms of exposure, you'll be exposed to this form a lot more. And I hope by now you are not a stranger to look at something like this. Like if you have sine of 2x, and if you happen to have 2x in the denominator, that 2 would also equal to 1. So the understanding right here is that whatever in the sine function has got to equal to the denominator. Okay? If you see 2x, you want to have 2x in the denominator. If you see 5x, you want to see 5x in the denominator. Now, a couple of things to go over right here, and that is, it is not about canceling each other, because I've heard some people saying they cancel each other out. No, it's not about cancellation. Okay? It's about, well, as I said last time, I believe that you will be able to understand the proof of this when we learn something called L'Hopital's rule. Okay? But for now, you can use the graph. I think I showed you the graph last week to say like, hey, this is the graph. As x approaches 0, the graph heads to 1. Okay? Now, so what kind of question that I'm a little bit concerned about is something like this. So if I have something like this, and believe this is on your one of the worksheets too. Okay? So let's see, right, not here. Let me try again. So if you ever see something with tangent, come on. All right, I'll just write it down then. Limit as x approaches 0 of sine of 10x over 2 tangent of 3x. If you ever see something like this, there's only one response. We had not done anything with tangent. That means tangent's got to go, got to be changed. So, I mean, tangent is equal to sine of a cosine, but when you actually change it to, or simplify to a simple fraction and not a complex fraction, so what you would have is sine of 10x, right, in the numerator. You have a 2 in the denominator. The tangent 3x becomes cosine of 3x in the numerator and sine of 3x in the denominator. So you're right, yes, you're right. But now, what's next? Well, what is the problem right here? Well, the problem is really about these two. Because when you substitute substitute 0 into these x's, you get 0. And you have 0 over 0. So now we have to design our limit in such a way that it will be something nice. So, yes, but because tangent it's in the denominator, as you divide by a sine of a cosine, you multiply by the reciprocal. All right. So what we're going to do is to split this into 3 separate fractions. And then at the same time, I'm going to put the 2 in the very front. Now, some people would ask, Mr. Chen, how do you know that this is the way to do it? And my explanation is, well, I'm just operating within the philosophy of, or the limitation of equality. Whatever I'm writing, it's exactly equal to the previous part. Therefore, I could do it. And I am seeing some benefits and advantages of doing this because, well, what do we want to see underneath the sine of 10x? So let's make 10x here. Well, how? Well, first, we cannot alter the value. We cannot just put an x right here. But what you could do is to multiply by 1 in the appearance of x over x. x over x is 1, right? So you can multiply by 1.
But then how would it, or how would you, like, wait till 1 if it's just x, not 10x?
Well, it's x over, well, we're on the path to 10x. But first, we need to have an x. Yes, we will need a 10 as well. Well, then we say, hey, put a 10 right here. But we will also need a 10 in the numerator. No problem. 10 over 10. X over x. So now, can you see the first fraction being very nice right now? Let's take care of the second fraction. Well, we got x in the numerator, but I think we lack something. For this numerator, because we multiply by x over x, which is 1. Okay? Now, just a little refresher. Do you remember when you do common denominator, what do you need to do? Right? What are you multiplying? 1. You're not changing the value, but you're changing its appearance. This is a very important understanding that you can multiply by 1 anytime you want, as long as it helps. Okay? The same thing it's applied when you do what? Do you remember you did rationalization? What do? You multiply by root 2 over 2, which is equal to 1. All right? So that was a very important moment in my math journey, which is, oh, I never thought 1 is so darn special. It could appear in so many different faces. So that's why we have x over x, and we happen to need an x in the second fraction as well. But what else do we need in the numerator of the second fraction? A 3. So 3 in the numerator and 3 in the denominator. That's also equal to 1. Okay? So now, are we good right now? Well, if you take the limit of this as x approaches 0, that's equal to 1. The limit as x approaches 0 for the second fraction, it's also equal to 1. So all it's left, it's the last one, which is cosine of 0, which is also 1. So the final answer, 5/3. Okay? So don't freak out, but make sure you know what you love to see. You have to have a preference. If you don't know your preference, you better develop the preference right now. And make sure you know how to create your preferred appearance, okay, of these fractions. Okay? So make sure you have this well understood. Okay?